Welcome, welcome. Thank you for joining us for another episode of Open Dialogues. Open Dialogues is a live stream webinar series designed as a conversational companion to the AI infused newsletter. So, we're going to take around 30 minutes to have a roundtable discussion around the three rotating topics as we described in the description of this episode. So, with us today is Ben, Bilal, and myself and Stratos. We'll go in order with a little bit of a self introduction. Benjamin, could you start us off and tell us a little bit about who you are and what you do?
Yes. So I'm an ontology engineer. I have nearly 3 decades experience developing in what nowadays is sometimes referred to as symbolic or deterministic AI. I have a lot of familiarity with upper ontologies, and that's where most of my work has concentrated, as well as in domain modeling and inference design. I'm very interested right now in hybrid approaches that look to incorporate symbolic AI with generative or non-deterministic systems. Large language models being one example of that.
Thank you, Benjamin. Bilal?
Yeah, Bilal is a hybrid engineer. Okay, and my current position is senior knowledge graph architect, spending my days helping data to make sense of itself, passionate about learning, exchanging ideas, and connecting people through knowledge. I believe that, in fact, good conversations like good ontologies should create clarity, structures, and sometimes unexpected links. So, yeah.
Excellent. Thank you, Bilal. Uh, my name is Joaquin, and I'm a community knitter. And yeah, I'm going to be facilitating this conversation. Stratos, would you like to say a little bit about yourself?
Yes, of course. So, hello all. I'm Stratos Kontopoulos, obviously a Greek, similar background as the guys before me. I'm a knowledge graph engineer. Have been doing that for over 20 years now. I started academically, doing a PhD on those exact same technologies when they were heavily academic, a heavily academic subject. But then eventually they became quite popular in the industry as well. So after doing a few years of academic slash research work on those technologies, I then shifted to the industry. And I have been working on various domains ever since, starting from cultural heritage, digital preservation, security, defense, pharma, fintech, you name it. So I'm a, let's say, a rare hybrid of academic slash industrial practitioner. And yeah, as the guys before me already said, I'm also very interested in this neurosymbolic combination, the way of combining the symbolic AI techniques, mostly knowledge graphs currently, with the hot new kid on the block, Gen AI and LLMs. And actually, things are very interesting in this aspect.
Excellent. Well, I think we've opened the door for the first topic of observation. We were going to disambiguate the difference between label property graphs and semantic knowledge graphs. If we're going to be framing this conversation around the ROI of deploying enterprise knowledge graphs, we have to do everybody a service and define what a knowledge graph actually is and what the differences are between them. So I think just in the same order, we could just kind of start socializing the concepts. Benjamin, would you like to start us off?
Well, okay. So this, let me put something on the table. I mean, and ask if people think this is a fair distinction. I think of semantic knowledge graphs as being, in some sense, type level representations. I mean, in some sense, and at some high level of abstraction, what you're trying to capture are things that at the schema level that are almost like quantified rules. We're talking about subclass relations and other relations that are in some ways almost syllogistic, whereas labeled property graphs are more instance level. And it might even be fair to say that semantic knowledge graphs can provide a kind of framing structure and an ontology framework, if you will, for labeled property graph representations, or at least better labeled property graph representations.
Mhm. Yeah. In fact, I think I want to add something to what you said, in fact, Benjamin. Okay, so because I think before comparing label property graphs and semantic knowledge graphs, I think we need to clarify what problem we are solving. Okay, are we trying to build graph application, or are we trying to preserve and govern enterprise meaning? So in this context, the labeled property graph, in fact, is excellent, okay, when the objective is to model connected data, okay, for operational use cases, like, for example, for recommendation systems, fraud detections, dependency analysis, and customer journey or network, in fact, exploration. While semantic knowledge graphs, or the knowledge graphs that are powered by the ontologies, or they have the ontologies behind SIEM, it doesn't only connect entities, but it makes the meaning of those entities explicit, okay, through ontologies, controlled vocabularies, and also constraint and formula relationships. And this is what allows knowledge to become interoperable across systems, teams, and recently AI applications. So in fact, if we need to position the labeled property graphs and semantic knowledge graphs, we need to ask the questions. What are the questions that the labeled property graph can answer, and what are the questions that the ontologies answer? So for me, for example, I personally see that a labeled property graph tells us how things are connected. Okay, but for semantic knowledge graph tells us what those things mean, and why they are connected, and how that meaning can be used consistently across the enterprise.
So would one way of encapsulating that maybe be to say that labeled property graphs concern network analysis or graph analysis, whereas semantic knowledge graphs concern inference?
Totally. Yeah, I totally agree. I mean, that was what I was planning to say anyway, that their main, let's say, distinction is the fact that for labeled property graphs, the relationship is the first-class citizen, while for the semantic knowledge graphs, let's say the IRI is the first-class citizen, the statement, and it's expressed as links to the respective definitions. So let's not get into the definition of what a knowledge graph is. There are so many out there. I don't think there is a consensus here. I respect that both approaches that we're discussing now, let's say, serve the field of knowledge graphs. However, yes, I call semantic knowledge graphs the ones that are based on W3C, the W3C ecosystem of tools, and labeled property graphs, the ones that are based on the Cypher query language, or GQL, which is the new ISO standard. To me, as you guys already said, it depends on the use case totally. Labeled property graphs are great at studying the relationships between the entities and the data points, and you can do graph machine learning on top of them, graph analytics, things like that. So you can analyze networks. They're great at those kinds of use cases. While the semantic knowledge graphs are very good in data integration, especially across different sources, federated queries, and of course, semantic reasoning. So are they enemies? Are they friends? For several years, there used to be a holy war between the two approaches. But thank God, I think this is now behind us. And there are, for a few years now, I believe there is, let's say, a tighter collaboration between the two. I don't see any warlike cries or shouts anymore. I believe that people like us who are experts on the field, we can use each one depending on the domain at hand.
Mhm.
And sometimes we can also go towards hybrid approaches where you could have both of them and get the best from both worlds.
Yeah.
I just want to say, purely from the perspective of ROI, if somebody chooses to develop a knowledge graph, an enterprise knowledge graph, they're not just looking at what kind of problems that they're looking to resolve, but the market maturity of the technologies, the talent that is available to fulfill the obligations of that kind of use case with those kinds of technologies. One distinction I don't think we made, and something that's not immediately clear for me, is I know for a fact semantic knowledge graph technologies are all backed by W3C standards, and they're open source and they're mature and they've been in use since the 70s or even far longer than that. However, for the label property graphs, I think that's based on proprietary languages predominantly, and it's now only until recently that we're coming out with some sort of open source version of that. So licensing is a important factor in identifying how you want to approach this, and also the speed to development. So with label property graphs, I think a lot of people get enamored by the facility of taking a PDF or taking a corpus of documents and blending it down so that you get relationships and clusters of patterns of words and how they're associated with each other, but you don't get the richness, that keyword that Bilal has been using, interoperability of context and meaning, unless you accurately represent it in an ontological model. Um,
Yeah.
there is a question, sorry, Ben, please go ahead.
Oh, no. Well, I didn't mean to interrupt, but yeah, I mean, I think if we're talking in terms of ROI, it's really important to bring out I think there's almost a trade-off here, because I mean, the more expressive your language and the richer the ontology that's underpinning it, the the costlier development becomes. But both because you're very often you're trying to conform to a standard, but also the whole process of knowledge discovery, I think, becomes more complex than it may be, strictly speaking, with labeled property graphs.
There is a question that I am not qualified to answer because I haven't looked enough into context graphs. Marianne is asking, isn't a context graph a semantic knowledge graph? And my visceral response to that is no, but I don't have the arguments to articulate this. Does anybody want to take this?
Well, again, similarly to knowledge graphs, there's no consensus in what a context graph exactly means. I have seen several definitions out there. To my best understanding, the context graph could be a part of a knowledge graph, of a semantic knowledge graph, as Marianne is saying. And what part of that is it? In my understanding, it's the part that justifies how decisions were made, let's say, at an enterprise setting, right? So it responds to questions like, how did we reach this decision? What is the chain of thought behind that? Who took this decision? Who is responsible to be asked about those things like that. So in my understanding, the term context graph initially probably was irrelevant to knowledge graphs, but the knowledge graph community immediately grasped the opportunity to make it part of the knowledge graph, let's say, ecosystem. And I think it's correct because we currently have the tools and the ways, the formalities to represent all this kind of knowledge. So context graph, in my understanding, is indeed part of the semantic knowledge graph.
Yeah. No, I agree with you. In fact, Stratos, because when we talk about the knowledge graph, in fact, indirectly we are tackling three type of assets: the data asset, the metadata assets, and the knowledge assets. Okay, so for example, the data assets is the raw or the raw or structured facts, okay, stored in our system. And we have now, and then we have the metadata asset, where we have information about data, such as, for example, source, format, okay, the time of collecting this data. And this type of data also can be considered like a context that can be connected with the graph. And then we have the knowledge asset. And again, the knowledge asset, in fact, it contains what? It contains the meaning, the context, the relationship, the constraint, the rules, and the business interpretation around the data. And the business interpretation around the data, I think this is where the the context graph appear. I think I personally see that from my perspective, you can't build a knowledge graph without taking into consideration the process of the contextualizing, okay, the entities, and bring a context into the knowledge, this knowledge graph, because at the end we need to build something that has shared understanding and shared conceptualization and formal language. And in order to combine these three things, we need specifically we need to take into our consideration the concept of context, that I think it's a part of a graph also, and part of specifically a knowledge graph.
Yeah. Yeah. I think context presents special problems, and in addition to being a really critical part of this discussion. If one is trying to capture the type of information that Bilal was just talking about, so for example, metadata concerning intention and provenance, are dynamicism, such as you have like with temporal context, where things may be true at one time and not at another. Or if you're trying to capture epistemic context, where someone believes something, one person may believe something's true and another believes it's false. A complication that introduces when you try to reflect back into the knowledge graph is that it's going to mean treating graphs and subgraphs as first order objects and making assertions about them. And that is an added complication, and it's going to impact the semantics in ways that may make it difficult to compute, to say the least. But I think it's something that has to be kept in view at the same time.
I think this is a natural transition into the second topic, which we've kind of addressed, but we really didn't explicitly lay it out on the table. There is this idea of preservation of knowledge in an asset, whether it's as Bilal was distinguishing data, metadata, knowledge, artifacts, right? Whatever thing represents decisions and information and context behind multiple parties at a particular time in a document format, that is human and machine interoperable. I mean, that's the best way of that's the ideal goal of having all your information be available to machines and people simultaneously, so you can fully take advantage of all the things that you're creating. But yeah, let's get into that. And I guess, just to put a synthesis from my mind, I see semantic knowledge graphs as a heavily engineered, structured, several layered cake of meaning, controlled vocabulary, thesaurus, ontologies, and the graph data being tied to the ontologies, making this a very rich, interrelated map. The graph analytics is a flatter representation that just shows nodes and edges, but it doesn't accurately describe what exists beyond a static representation of things. And then the context graph, I think, is just a derivative of semantic knowledge graph, like a Sparkle query instance in a graph format. I think that's just like a graph data set that has kind of a provenance and description, but it's not a it's not as robust as a semantic knowledge graph. Anyways, sorry, let's go into the knowledge assets, and maybe we can start backwards from Stratos and work our way to the left.
Yeah, sure. So actually, you covered me fully. One of the strongest reasons, in my view, for investing in a knowledge graph is definitely knowledge preservation. The enterprises have for years trying to avoid that, have been trying to avoid that, although the knowledge graph community has been trying to explicitly refer to the advantages of this approach. Many enterprises have indeed adopted semantic knowledge graph infrastructure to provide, let's say, human and machine interoperable knowledge of their internal functions. Now with LLMs, again, enterprises have become maybe a bit lazy. They wanted to, immediately give everything to the LLM and make sense out of that automatically. But that again is not the case. And I think now enterprises are mature enough to be realizing that they need some kind of what others call semantic layer, or anyway something that brings value to the implicit knowledge that is found across documents, spreadsheets, systems, dashboards, people's heads, right? So a knowledge graph, a semantic knowledge graph, can give us a way to capture that knowledge in a nutshell, in a form that people can understand and machines can process. And this matters a lot. Why? Because this enterprise knowledge should not disappear when someone leaves, right? Or when tools change or teams reorganize, it should remain there, reusable, explainable, and actionable, and alive. It's a living thing. It's not something you build once and then forget about it.
Yeah. In fact, in this context, also, Stratus for the preserving, in fact, the knowledge assets. It means that preserving the enterprises understanding of their own concept, okay, relationships, rules, and context. So it's not only about keeping the data available, because we have the data, we have the availability of the data, but it's about ensuring that the meaning of that data, okay, remains clear, usable, and trustworthy over the time. So in fact, one of the problems that I think enterprises suffer from is the semantic continuity, because in order to preserve, okay, the meaning, you need to ensure that you have a system that can ensure the semantic continuity, because things are changed over time, okay, and in order to control these things, the systems must be aware, okay, of that changes. A lot of things start to become deprecated. A lot of new things start to become, in fact, active. So in this context, the data asset tells us what the record is, or what was recorded, okay, what was recorded. But the knowledge asset tells us what it means, how it should be interpreted, and how it relates to the rest of the enterprises. And here, in order to put everything into a good circle, I will say some expressions that I always believe in, that are the following. So data can be stored, but the meaning must be modeled. Okay, and also the real asset is not only the data. So if you have the data, it doesn't mean you have the strategy to keep this data or preserve the data, but but what we are interested in, it's the shared understanding around that data. Okay, and this is something very, very important. And here, so the value, what I want to explain here, I may intent, in fact, is that the value of preservation is the continuity. Okay, so because continuity of meaning, of decisions, and of reusability, and specifically in the era, in our era, and specifically the AI era, that is a governed meaning becomes a strategic asset. So if and this is, okay, one of the things that make the process of keeping and preserving, the meaning of the data somehow complex. Now,
Yes. So, well, I mean, this really brings us to the issue of, I guess, what we might call, historiographic issue, historiographic problems. Um, a central problem confronting knowledge capture, I think, it concerns the fact that very often the priorities and the interests that govern enterprise knowledge capture at a given time are not necessarily the ones that future historians and archivists may have in coming back to that knowledge. And I think this bites us at a number of levels. I mean, on the one hand, you may just not be capturing the data that that you need, or that future researchers are going to need. So for example, I mean, like with the European post-war recovery, and businesses that were operating then, people may not have been recording the kinds of details associated with supply chains that now historical researchers are interested in studying there. And then more generally, I mean, with the knowledge modeling, it's an issue here too, because semantics change, and the ontological representation there is likely to reflect current models, but future models may presuppose a different ontology, and so now you've got a translation issue of how you're going to map between those if you're going to do effective inference on what's being captured.
There's a lot of problems that we put out here and a lot of different angles that we're exploring. Let me see if I can tie it back down, and if you guys are fine, we can go just a little bit over, because I think this is heating up our brains and see a little steam coming out of everybody's ears. Um, if we're looking at this strictly from the ROI of deploying an enterprise knowledge graph, and someone's looking to make the decision on what they need to spend their money on to make the business capable of resolving some sort of problem, or unblock some sort of funnel, like a bottleneck that they have in their production capability, in their analytical capability, in their decision making capability. Um, we're looking at organizations. Organizations are groups of people that are bound together for a purpose. We don't live off of the sunlight. We're not plants. We live off money, and we have promises and arrangements and contracts from these organizations. So we need to keep track of the promises, the contractual obligations we have, the people that are involved, the money that's flowing through the organization, and how it's being deployed, how we're compliant with legal matters in the society that we live in. And we use software and these systems to kind of keep track of all that. Um, but the computerized systems have a defined model of how they represent meaning and knowledge. And every software vendor has their own way of viewing the world. When you purchase a software, you're essentially purchasing their representation of the world, and not all softwares are interoperable because they don't share the same meaning, the same model, the same words. So I think the argument we want to make in this is, how much money do you want to spend, and do you need to quickly deploy some sort of static analytical approach that is done in increments? Do you want to create a long-term uh, uh, organizational capability that allows you to capture the knowledge of decades of workers and different things as an organization evolves? Because everything is an asset, it's an intellectual property. um so if you encode things and a semantic knowledge graph and capture knowledge across time, you are essentially reinforcing the value proposition of the organization and also enabling downstream applications because when you model meaning once and you tie all the software in a coherent manner, then you can reuse data and you reduce the labor spent to clean and manage and organize and process things again and again and again, which is a waste of labor. I mean, you hear people talking about data janitorial duties all the time. So I'll be quiet now, and maybe we can go back and do the circle and see what everybody else has to say.
Okay. Yeah. Well, I mean, it seems to me we're talking about a point, you know, you bring up in bullet item number 3, and this is reusability. And a fundamental question is how do we optimize in data capture and knowledge modeling for reusability of data and reusability of knowledge?
Do you have a follow up comment to that, Ben?
Uh, it's a tough problem,
Yeah.
but it's yeah. I think domain knowledge and understanding of the use context and the culture is essential. And that may have to be may and probably does have to be reflected back into the modeling process itself.
Yeah. In fact, as you said, Ben, it's tough problem. Okay, yeah, because generally speaking, we can see that the return of investment, okay, comes from reducing the knowledge loss. Generally speaking, okay, repeated interpretations, onboarding frictions, inconsistent terminology, and fragile system-to-system mapping. Okay, so this is things that can help us, okay, to increase, okay, the return of investment, because when a know in fact, if we connect this point into the knowledge preservation, when knowledge is preserved, okay, as a usable semantic asset, the organization does not need to repeatedly rediscover the same meaning or the same terminology every time it builds a new system, dashboard, integration, or AI use case. And here, in fact, can make what can make the semantic knowledge graphs something that's very, very important for the enterprises, and in order to ensure a good return of investment, it's related to their capabilities. Okay, what are these capabilities? Okay, in fact, I don't have numbers, but based on the experience, the capabilities are the following. For example, the shared definition, the entity resolution, the provenance, the mapping, the context, the relationships, all this component. If we try to combine them, okay, in one place and centralize them in one place, we can ensure that we have, okay, a good return of investment. And this is in fact, we can touch this point specifically in the era of AI, when people start to build, for example, graph rack systems, okay, and for example, semantic search, okay, systems. We can touch the need, okay, for the knowledge graphs, in order to make people trust the results that our AI systems can bring to them. So I think the how much money, okay, it depends on the big of the problem that you are trying to solve, and also the hierarchy of the hierarchy of the company and its size, because it's very, very hard to say something generic without relying on set of metrics, without relying on set of requirement. Yeah, so but what we are sure about is that the capability of semantic knowledge graphs can solve the majority of the problems, but at the same time, we don't need to speak about the knowledge graph as the gift that is coming from God, and it doesn't have any flaws. Okay, it's just a part of a system. Okay, and this is obvious in in the architecture of the AI system. You can find that the knowledge graph is just it's just one component, okay, that solve specific problem. But in order to make good return, you need to combine a lot of other components that can communicate with each other in order to bring a good and perfect result and make your return of investment improved uh, over time.
Yeah, those are all great points, guys. And the last point that Bilal made, I totally agree that we shouldn't be promoting the knowledge graph as the perfect solution, and it will solve all their problems. And you first, you don't need anything else, and secondly, it's not something that is complex to develop and maintain. I am, I mean, I'm now convinced that most enterprises, no matter their size, they are convinced that they probably need such a kind of layer, let's say, on top of their data assets. Why? Because they want to capitalize on the knowledge that is there. They want to make it, actionable, and they want to make it processable not only from humans but from machines and AI agents nowadays. But I'm usually, whenever I join a new project or an enterprise that wants to set such a knowledge graph infrastructure up, they tend to ask me, okay, so what is the return of investment going to be? I'm giving them, the things we discussed. Look, you're going to be able to capitalize on that and that. But they're saying, no, I want to know how faster will my queries be? How, is it going to be 50% faster? Unfortunately, there is no easy answer here. I mean, you cannot come up with numbers regarding how easier your life will be. I assure every potential client of mine that your lives will be much easier. Things will be much more plug and play, like Lego bricks. You won't have those brittle, fragile pipelines from data source to data source. Plus, the overall exercise of creating this knowledge layer is valuable in itself for the enterprise, right? It's going to bring consensus between teams. It's going to bring ownership. Different teams will own different parts of this knowledge layer. This whole exercise is valuable in itself. And if we add on top of that the added benefits that you have machine processability and understandability and explainability of all this stuff, right, by the AI agents, then you have huge return of investment. We cannot quantify that, but it's definitely valuable.
This is hard. This is hard because there's no one
Totally.
size fits all. And if you're a small organization, if you're a large organization, if you're a young organization, if you're an old organization, if you have mergers and acquisitions of other organizations, if you split into many different areas, if you have deep reservoirs of knowledge or seemingly superficial areas of function, it all has an impact on the complexity of this. How many software systems do you have? Um, yeah, and the time to value is also a component to take into consideration. I mean, with label
Totally.
property graphs, you dump a couple documents in, or you dump SQL queries out, and you visualize your data sets, and you can have a different view of your existing data set. But for long lasting organizational capabilities, that requires a multi-talented team to come and to do knowledge extraction, subject matter expert interviews, and develop the infrastructure. And that's not overnight. That's a couple
Yeah,
quarters just to get
yeah,
to a core consensus
yeah,
on what the hell you're even trying to model, what kind of knowledge you're trying to represent.
yeah. In,
Um, sorry
so,
for the clickbait
uh,
title. We don't have a clear answer for you.
uh,
But
I want to add, sorry, Joaquin, I want to add
yeah,
something here in order to understand why we have this problem. And I agree with Stratos because he mentioned something that each time we start a new project with new customer, we suffer from some questions that you need to spend time in order to convince them life is not easy to achieve what you want. And the problem here, what I think the risk is in the industry, that is in the industry, is that we sometimes call every connected data set a knowledge graph. But a graph of connected data is not necessarily a knowledge graph. So the knowledge graph comes from explicit meaning, shared conceptualization, governance, the ability to use that meaning beyond the original application, and a lot of other assets. So the problem is that, and in the majority of the times, we start with customers that want knowledge graphs powered by ontologies, semantic knowledge graphs, but at the end, based on their requirement, they need only a property graph. They don't need any ontology or something. Okay, yeah, and this is in fact one of the issues. Okay, that can we can face. Okay, with customers in order to convince them that you don't need this, but you need this that is based on property graphs or something like that. But the risk in fact in understanding what each component covers.
Yeah. Getting buy-in not only from the customer, but from the subject matter experts who are the source for the knowledge capture is a whole topic in its own right, I think. It's
And it's totally valuable. If you have access to this kind of knowledge, it's a blessing. Because I have been in projects where I wasn't, let's say, allowed to approach subject matter experts for several reasons, and I mean, you cannot proceed. It's that far you can go. I mean, you can go farther. It's a blessing, in my view, to have access to subject matter experts. Yeah, and definitely they have to own this process, right?
So apart from the requisites of knowledge, experience, competencies with these technologies, you also have to get buy-in from the organization. And the organizations, when they're dealing with new technologies, don't want to give you $500,000 in one shot. They want to give you 50 grand, and they want to see what happens, and another 50 grand. And did we blow up? Okay, another 100 grand. So also working in that incremental fashion, it's kind of hard to prove value and get subsequent investments if you're not actively able to demonstrate something that is functional. Or hey, are our queries faster now? How much faster are our queries? It's
exactly. Yeah, I mean, it really it forces you to think and work in terms of proofs of concept. And while that can be sort of useful, it can also preclude the kind of deeper, more principled approach that you need, to build a system that is going to scale and be sustainable for the long term.
Plus, sometimes you are forced to fit your work in 2 week sprints or things like that, right? While knowledge engineering work is I mean, it has a big cognitive aspect there, and it's not that you can definitely promise that every 2 weeks you will be coming up with a new iteration over the proof of concept. Sometimes you have to be speaking to multiple people, that you might be modeling something for days, right? So it's not, let's say, like traditional software engineering projects. It's a completely different beast.
In fact, in this context, I used to say to my customers, this is the ontology that fits your requirement, but it's not an ontology that other ontologists will evaluate. Okay, because it's bad. Yeah.
I guess the biggest takeaway for me is the time to value is a relative figure of the ROI. Because until something is fully viable, you can't give relative measures of cost savings or capability enablement. We saved your data scientists half of the year having to clean this data, and you can pull it whenever you want and run it in your machine learning algorithms. And now you can run that algorithm 64 times instead of just 16. Then you have to look at their salary, and you have to slice what does that time, how is that valued, and what does that provide in terms of revenue. Um, but yeah, this is a hairy conversation. I am so sorry for the promise. This is an excuse to have another conversation, and we invite you to have more questions. So yeah, thank you for joining us. Any last words before we sign off?
So many things to keep discussing. So let's have a second iteration of this discussion. Yeah, I don't want to touch on any of the last things you mentioned because it's going to, spin up a new round of discussion.
Ben, Bilal, all good? All right. Well, thank you all.
Thank you.
Take care.
Bye.
Bye bye.